Good morning or good evening all. So before we start, I would request you, if you like my video on indices, then please like it, click the like button and do subscribe so that it motivates me for publishing more free videos on learning mathematics. So with that I will start. So what is indices? So for that we will start with multiplying x y times. We write it as x to the power y. Here x is called base of x to the power y, and y will be called exponent or index of x to the power y. So these are the two terms that is normally used. Everywhere you will find this. Now suppose if you multiply 2 3 times, it is base is same as 2, and what will be the exponent? 3 times, so it will be 3. Result is 8. So x to the power y equal to some value. Consider this value as a generic value as a. So what will be x? X will be called yth root of a. Yth root. Yth root means if there is some common factor, that is means after breaking it a into common factor, if you get y, some common factor is multiplied by y times, so you can take one factor out and that will be the value. So let me give you one example so that it will help you understand much better. I will first start with y as 2. So what x becomes is root of a, if we literally go by this convention, but it is more generally written as only root a. And if y equals to 3, so x becomes cube root of a. If y equals to 4, then x becomes 4th root of a. So in this way, and so on. And so on, yth root of a. Y can be any number. So here we are considering y as integer, which is positive. Okay. So before I erase this one, just I will pause for 5 seconds and we'll move to next. Okay. I'm going a little bit slow here, assuming some of you do not know anything of indices. So as a textbook study, it's like we are all starting from scratch and from the page 1 of your textbook. In that way I will cover every topic. So now root over 4, what is the value of this one? So root means if you have two factors multiplied to same factor, then we can take one out and that is the value. So it is root over 4 equal to 2. So here if a, we have seen x to the power y equal to a, so x equal to yth root of a. Here we have taken y equals to 2. When we say y equal to 2, it becomes a simple root, and when we here we assumed a equal to 4, so these two together makes yth root of a as root over 4, result is 2. But if we we take a as minus 4, so this is an imaginary number, because we all know that we cannot find root of a negative number. So root of a negative number does not exist. But what if it is a cube root? So if I have taken a simple number for which the calculation is easier, so cube root of 27 equal to 3. But what is for minus 27? Here also we have taken two scenarios, plus and minus. Here also we are taking two scenarios. But here interesting thing is minus 27 is the result of multiplying minus 3 times. So for cube root, from this 3 we take 1 out, and that becomes the result. Okay. So this is a, yth root of a. For this, if a is negative, then x equal to real for y even integer. Okay, y, sorry, this is odd integer, and imaginary for y even integer. See, when yth root of 4, yth root, this y was true, even, then when a was negative, it was imaginary. Okay? So when y was odd, means 3, at that time when a was negative, still it had some real value. So this is the basic difference, like root and cube root, or any even number and any odd number. If you try, means with an eventh root, that is not a correct way of saying, but yth root of a, when y is positive, then negative yth root does not exist. But for odd, it will always exist. So let's move to next things. Yeah, there are certain laws of indices. We'll learn those now. First one is a to the power n into a to the power n. This is the most basic one. A to the power n plus a. We'll try to understand this one. What does it mean by a to the power n? This is a into a into a n times. A to the power n equal to a to the power a n times. So together, left hand side of this one, what it becomes is equal to a, we are multiplying, this is n times and another n times, so we are actually multiplying a this many times. Here m times, here n times multiplied. So total m plus n times. And by definition, a to the power m equal to m times multiplication. So m plus n times multiplication means a to the power m plus n. So this law is proved. Okay. So this is the first law, that is the very basic law. Now I will move to the next law. This one was for multiplication, now this is for division. For multiplication it was addition in the exponent of the index part, here it is subtraction. So it is just a simple thing. So again another, this one was second, third is a to the power m to the power n equal to a to the power mn. And what will be AB? The two numbers are coming into picture. Okay. So it will be a to the power n, b to the power n. See here, a to the power n divided by a to the power n. Base was same, but the power or the exponent or the index was different. Here see, this means a to the power n divided by b to the power n. So here exponent is becoming same, but the base is different. So, and definitely b will not be 0, that is no need to mention. Okay. So these are the 5 laws. On the basis of that, the complete indices chapter is established. So now we'll try to find some common values. Let's see if we can find out with these indices. X to the power 0 equal to what? We have taken, when we have taken x to the power y, so y was always a positive integer, but what we haven't considered y to x to the power 0. But when we considered y as a positive integer, but these laws always hold for any real number y, any real number. So exponent can be any real number, no problem. Well, actually the value is 1, but how it is 1, we'll prove that. 0 can be written as any number minus itself. So from this property we know this. So m minus n in the exponent can be written as x to the power m divided by x to the power n. So here x to the power m divided by x to the power n equals to 1. Okay, so this is simple. Now we'll try to find out x to the power minus 3. We considered only positive exponent, positive integer, but 0 we have seen that now it is a negative integer. So for negative integer we may think of like this: multiply numerator and denominator by positive of this exponent. So by law we know that when we multiply, its exponent becomes like this, and this remains unchanged. So it becomes x to the power 0 by x, and x to the power 0 is what? 1. So when the exponent or the index is negative, that means it is the inverse of the same with the index as positive. So in general we can write x to the power minus y as 1 by x to the power y. Okay, where x is not equal to 0. Okay, so we'll proceed further. If we think x to the power minus 1 by 3. So from its very basic definition, we know x to the power y equal to multiplying x y times. So x to the power 0 is multiplying x 0 times. That does not have any meaning. But actually we proved that x to the 0 is equal to 1. Actually any number to the power 0 is 1. Similarly, x to the power minus 3 means from its very definition it is like multiplying x minus 3 times, but this does not have any meaning. But when we proved it, we found it x to the power minus 3 is equal to 1 by x cube. Similarly, x to the power minus 1 by 3, it is a fractional number at the index or the component. So here you will find that multiplying x minus 1 by 3 times does not have any meaning. So what will happen? It will be from x to the power minus, in the index we know it comes like this. So this cube root of x. That's it. Okay. If you have any question, then you can give me your feedback on any question, and you can post me questions. I will try to reply. Now I will proceed more. Suppose some special cases, a to the power m equal to b to the power n. Okay, or okay, let's go with this one first. So if a to the power m equal to b to the power n, what we can say? M is equal, so is it equal to b? Let's see. We will write it like a to the power m by b to the power m equal to 1 implies a by b 1, and we know 1 is any number to the power 0. So for comparison purpose we kept this base as a by b to the power 0. So m can be 0. Okay. What if m not equals to 0? So we'll find that. If m not equals to 0, in that case we know a by b to the power n equal to 1. So for this to hold true, a by b should be 1. As we know, 1 to the power anything is 1. Okay, 1 to the power any real number is 1. So a equals to 1. So for m not equal to 0, so here for m not equals to 0, a equal to b, otherwise m equals to 0. Okay, so just see this for a minute. Any question, let me know. Okay, now we will go to another kind of property. Here we saw a to the power m equal to b to the power m. So here index was same, base was different. We will do something different this time. Here we will make the base different and base and index different. So anything we can conclude from here, we can conclude a to the power m by a to the power n equal to 1. So from laws of indices we know that at the power it will be subtracted. Again we can write it as a to the power 0. So m minus n comes to be 0. Implies n equal to n. So if you find any condition like this, a is not equal to 0, 1 or minus 1. So m will be n. Why I am saying a not equal to 0? If it is 0, so 0 to the power m is what? 0, and 0 to the power n is 0. So it is already an identity. So whether m equal to n or not, that doesn't matter. 1 to the power n is always 1 and 1 to the power n 1, so it is also an identity. So those things we have excluded, so that for 2, 3 or any other real value we find a common relation like m should be n for this whole true. Okay, so this is in short what is there inside your laws of indices chapter. There are few, actually 5 laws that we have discussed, and 2 more special cases like a to the power m equal to a to the power n. For that what happens, and a to the power m equal to b to the power m, what happens. Those things we have discussed, and in the next class we will take some problems on this. So with that, I want to thank you all for being patient and attending this. And again I will request, if you have liked this, if anyone has learned something, and if somebody already know these concepts, so if it refreshed your knowledge and helped in revision, so please like it and do subscribe. With that, thank you. Thanks everybody for joining. Yeah, have a good day.